Okay, so here is problem 4 from finding a function from a derivative and a point. And first of all, I think there was a typo in the problem, because in the problem it says, here's by the way, this is the answer that the book gives, and I was able to find this answer, but not the way that the problem was formulated. So it says a curve is defined only for positive values of x, and the gradient of the normal to the curve at any point is equal to the x-coordinate at that point. So I think this is a typo. I don't think they meant normal. I think they meant to say tangent, because I tried doing it with the normal and I could not get this answer. I got something totally different. Whereas if we say the gradient of the tangent is equal to the x-coordinate at that point, then I was able to get this answer that I got from the back of the book. So I think that this is a typo. I don't think it's the normal. I think it has to be the tangent. So a curve is defined only for positive values of x, and that makes sense because down here they say it's a natural log. So when you put in an x here, this function has to be positive. And the curve at any point is equal to the x-coordinate at that point. The gradient of the, and I'm going to say tangent to the curve at any point, is equal to the x-coordinate at that point. So this piece of information here about the gradient being equal to the x-coordinate at that point is really important. I could not do the problem using the fact that this was a normal. I could not get it. I can try and show you the work I did, but I ended up, by using the normal, I ended up with the answer y is equal to natural log of ex. And that doesn't match this. Clearly it does not. Okay, so I'm going to run this through by changing this to tangent, and I will be able to get this answer. So, assuming that this is the information that they gave us is about a tangent, then I know when I take the derivative of y, so I have y is equal to natural log of g of x, I know that when I take the derivative of that, the gradient is going to be the same as whatever the x-coordinate is. So, you know, when we have the gradient function, we plug in our value for x, and it calculates the gradient. Well, if the gradient is going to be the same as the x-coordinate, then the gradient just has to equal x. Then it'll just be the x-coordinate. Okay, so I know that the derivative of y equals natural log of g of x has to just equal x. But if I take the derivative of this guy right here, y equals natural log of gx, if I actually take that derivative, I would do a little u substitution, because g of x could be something real fancy, we don't know. So I'm going to say u is my g of x. So I can rewrite, I'm going to rewrite this using the chain rule. And u prime is going to be equal to whatever the derivative of g of x is. So therefore I can rewrite y equals natural log, instead of writing g of x, I'm going to write u. And then I'm going to take the derivative of that. What's the derivative of the natural log of u? Well, that would be 1 over u. So now I took the derivative of u, I took the derivative of y, and then using the chain rule, I'm going to multiply those together. So y prime is equal to g of x, g prime of x times 1 over u, and I'm going to go ahead and substitute back in. What is u? It's g of x. So therefore, the derivative of y is equal to g prime of x over g of x. All right, but I also, at the beginning, I said, well, that is going to have to equal x. So this, the derivative and the function, g of x, they are going to have to reduce down to x. So I can write that. I know, because of the information that I changed, which said that the tangent has a slope that's equal to whatever the x value is, I can say the derivative of the function has a value of x, because when that gives us the gradient of the tangent at a point. All right, so remember I changed that. The problem had said normal. I crossed that out and I changed it to tangent, because otherwise I couldn't get the answer that they got in the back of the book. All right, so let's keep going. So I took my y equals natural log of g of x, and I rewrote that as the derivative would have to be g prime of x over g of x. Well, I know that this has to equal x, so I'm going to set those equal to each other. So x has to equal g prime of x over g of x. So what I want is I want to figure out what g of x is, because they want me to write the equation of this curve. So I need to find out what is g of x. So I'm going to try and get g of x by itself. So I'm going to multiply both sides by g of x, and I'm going to divide both sides by x. So I'm going to get g prime of x over x. So in effect, these two are just going to end up switching places. So g of x is equal to g prime of x over x. So now I can go back to, let's see, is that what I wanted to do? Oh, shoot, g of x is equal to x over, yeah. Okay, so now I can go back to my original function. Where is it? Up here. And I'm going to substitute in for g of x. I'm going to put in all of this, okay, because that's another expression for g of x. So I'm going to go back to what they told me, which was my equation can be written in this form. And instead of g of x, I'm going to write g prime of x over x. Oh, I forgot to mention also, there is no c. You know, when we try and find the original position function by like doing the antiderivative, there's not going to be a c, because if I were to take the derivative and if I was going to have a c out here, that would change the answer. So there's not going to be a c. Okay, so when I take the antiderivative, if we were taking the antiderivative of this, there's not going to be a c. Okay, because that would change the value of the gradient. Okay, I probably didn't need to say that. All right, anyway, sorry, moving on. Okay, so now I've got an x and a y, but I have this extra variable sitting here, this g prime of x. I got to figure out what's g prime of x, and I can do that by using the point they give me. They tell me that a point on the curve is, what was it? It was e squared comma 3. So they gave me a point on the curve. It says the curve passes through the point e squared comma 3. So I can now use that to help me solve for what was g prime of x. So I'm going to put in y is 3, natural log g prime of x over, and then x is e squared. So now I have to solve this for g prime of x. Okay, so in order to solve this for g prime of x, I need to get it out away from the natural log. So I'm going to change the form here. I'm going to rewrite this. So natural log means it has a base of e, and this is the exponent. So I can rewrite this as e to the third is equal to this whole mess, g prime of x over e squared. Okay, so now I'm trying to get g prime of x by itself, so I'm going to multiply both sides of the equation by e squared. And I get e to the fifth is equal to g prime of x. Now I can go back, and where my g prime of x was, right here, I can substitute back in the e of 5. And so when I do that, I get y, therefore, this is the sign, therefore, y is equal to natural log. Instead of g prime of x, I can write e to the fifth over x. And that is the answer that they have in the textbook for the problem that I got this from. But like I said, when I did this, I used that information where it said the gradient of the normal to the curve. I changed that to tangent, because I could not do it by making it be a normal. It had to be a tangent in order to get that answer. Alrighty, sorry about that. That was if somebody else can figure out how to get that same answer by making it be a normal to the curve, I would love to hear it. But I had to change it to be a tangent in order to get that answer. Alrighty, bye-bye.